All right, good morning, everybody. December 12th, Monday. Hope your weekend was great. Today's agenda, we're going to take some notes. We're going to look at some introduction to bonding. This is chapter 6. Last Thursday we talked about Lewis structures. We're going to start using those a little bit to describe bonding. So today I'm going to introduce some types of bonding, and then I'm going to have you read pages 158 through 164 and do those problems 1 through 5 on page 164. Maybe that could get written up on the whiteboard if it's not already. Um, so today, let's get to it. Bonding. Now, the chemical bond, the definition is the attractive force that holds atoms or ions together. We haven't really talked about ions. We've talked about atoms right here. So, and what that means is whether we're basically everything, whether we're talking about the food that we eat, the air that we breathe, the cities, buildings, our homes that we live in and work in and all that, or that we're talking about you, and I know this isn't you right here, this is Harry Potter, but he's pointing at you, and whatever that is, food, manufactured items, or you, we're all here because atoms have bonded together to create something more complex. And so let's take this apple for example. We were start to break this apple down into pieces. We took a slice of that apple and we kept getting, smaller and smaller and smaller, and we got down to where we could see atoms, and here's maybe we'd see maybe something like this. Here's two atoms bonded together, and then we've studied a single atom, so maybe we could get to one atom, and then maybe we could even break that atom apart and look at some of the subatomic particles, proteins, electrons, and neutrons, which we've studied already. But going the other way, the way that these are all made is atoms bond together into more complex molecules. And so chemical bonding is where it starts to get pretty fun and pretty relevant to why we're here. So let's take a look at the first type of bonding we're going to talk about is ionic bonding. And one word I said that we hadn't learned yet is the word ion. Right there, ion. And so what is an ion? And an ion is defined as an atom that has a positive or negative charge. And let's take a look at what that means. Now, here's sodium. And sodium on the periodic table is right there. And it is in group or family number 1, the alkali metals. Okay, and we can see right here it has right here atomic number of 11. So that means sodium has 11 protons and 11 electrons. And that makes a neutral atom. When 11 protons are matched with 11 electrons, 11 positive charges with 11 negative charges, we get a neutral atom. They counteract each other. Okay, chlorine, same thing, right? Chlorine, which is, let's see, chlorine is right there. Now it's way over here in group 7, and you can see it has an atomic number of 17. And so it has 17 protons, positive charges, and 17 electrons, negative charges. And it's a neutral atom. And then some other things that we've talked about. Group 1, sodium, and this is what this shows. This is kind of the Bohr model. We just did Lewis structures on Thursday, and we could write that very similar just like that. It would look basically the same. In chlorine, we could do the Lewis structure for chlorine, and it would look just about the same as this. But this shows us the outermost energy level, or the valence shell, and we know because sodium is in group 1 here. It has 1 valence electron, and that's what that is showing. Okay? Chlorine over here in group 7 has 7 valence electrons, and that's what this is showing over there. So, now we've also talked about the noble gases over here. I'll just do helium because it's over here in group 8. These have 8 valence electrons, and that means it's full shell, and all these other atoms want to be like the noble gases. They want to have a full shell too. They want to have a full 8 electrons in their outer shell. Okay, so how does that happen? Well, chlorine's almost there. It needs 1. It's right there. It's right next door. It needs 1 electron. Sodium actually only has 1. So if it lost 1 electron, it would be happy. The shell inside this one is full. So let's do that. Let's say that this happens in nature. Let's say that sodium and chlorine are in the same area, and they decide, hey, sodium says, I'm going to give up my electron. I'm going to give this up, and I'm going to give it to chlorine. So all of a sudden, now we have a chlorine atom, or not a chlorine atom, a chlorine ion, and it's actually called a chloride ion, and we'll talk about that a little bit later. But so now we have this, and it's written like that because now it has 17 protons, positive charged protons, and 18 electrons. It has 1 more negative charge, so we write it as a chlorine negative. Over here, sodium is written like this because now it still has 11 protons, positive charges, but now it only has 10 electrons, negatively charged particles. So it has 1 more proton than electron. So it has a positive 1 charge. So, and then we know positive, like a magnet has a positive end and a negative end. Positive sodium and a negative, I'll do this one different color, negative chlorine. These two forces attract, and that is what we call an ionic bond. And that is described a force that attracts electrons from one atom to another. Sodium gave away its electron to chlorine, which transforms a neutral atom into an ion, and then those ions are attracted to each other. Those ions' opposite charges are attracted to each other. So that's an ionic bond, and that is one very important type of bond that we know. The other kind of bond that we're going to talk about is a covalent bonding, and this actually results from the sharing of electron pairs between atoms. So it's a little different. Atoms don't give up or take electrons, but they share them together. So here's a water molecule, and this large one in the middle is oxygen. And oxygen is, and let me see if I can grab this. Let me see if I can grab this this periodic table for the next slide. There we go, right there. It's going to be a little bit small, but just need to kind of show you where oxygen is. And oxygen is, let me see, oxygen is right there, and it's in group 6. And so you can see, and it has, let me see that, as atomic number of 8. So this is actually showing, this Bohr model is showing all 8 of its electrons. But the outermost level, the outermost shell, has 1, 2, 3, 4, 5, 6. Well, we're getting ahead of ourselves. It has 6 electrons in its valence shell. These are actually its electrons right there. 1, 2, 3, 4. One of these is oxygen, and one of these is from oxygen. So it has 6 valence electrons. Each one of these two smaller atoms are hydrogen. This is hydrogen. And each one of them has 1 electron. And that's a hydrogen electron, and that's a hydrogen electron. Now they still want to be like the noble gases and have 8 electrons in their outermost shell. So in this case, they've all gotten together and they're sharing those electrons. So now oxygen has 1, 2. Oxygen has, and I can count them, 1, 2, 3, 4, 5, 6, 7, 8. 8 electrons. It's happy. Hydrogen's a little bit different. It's actually up here. And hydrogen and helium, they only deal with the first shell, and so you have to think back when we did the Bohr models, that first shell only has the capacity to hold 2 electrons. So it's happy with just 2. It's full. It's like the noble gas helium. And so we're all happy. We're sharing electrons and we're happy. Now there are 2 types of these kind of sharing bonds or covalent bonds, and one's called nonpolar covalent. The other one's called polar covalent. And the only difference between these two is the nonpolar covalent bond, when 2 atoms share the electrons, those electrons are shared equally. They're shared equally. They're fair. They share them the same amount of time, all that kind of stuff. They're shared equally among the atoms, and you can see that represented here. They're right in the middle. The polar covalent, one of the atoms tends to hog the atoms, or hog the electrons a little bit. And you can see that here's this atom right here, and here's this other one. Kind of goes like this. And you can see this larger atom's pulling those electrons a little closer to the nucleus. So we say this one has a little bit more electronegativity. It pulls those electrons a little bit closer to its nucleus. And this is what we call a polar covalent. The electrons aren't shared equally. And in fact, one atom hogs them a little bit. It takes them a majority of the time. So, and we'll talk about more of these later. We'll talk about each one of these bonds in a little bit more detail, but that's an introduction. What I'd like you to do for the rest of today is read page 158 through 164, and this is actually on ionic bonds, so you'll start learning more about ionic bonds, and do problems 1 through 5 on page 164. All right, have a great day. Thank you.